So the essential question for this lesson, how do we solve systems of linear inequalities? So we're going to start by looking at a few definitions. So first, a system of linear inequalities is two or more inequalities with the same two variables. So for example, it might be y greater than 3x minus 4, y less than or equal to negative 2x plus 6. So that's an example of a system of linear inequalities. So a solution of a system of linear inequalities is any ordered pair which satisfies each and every inequality in the system. I showed you an example that just had two inequalities. You could have more. But the solution would be, again, any ordered pair, like 2, 1, that if you plug the 2 and the 1 into the x and the y respectively, into both of the inequalities, if it gives you a true statement in both of the inequalities, then it is a solution. If it doesn't, if either one of them or both of them are not true, then that is not a solution to the system. The graph of a system of inequalities is the graph of all solutions in the system. And that's what we are going to be looking at. So the only way to really show a solution or all the solutions to a system of linear inequalities is by showing what the graph looks like. Then you can identify what the solutions would look like based on the graph. So next, let's look at the steps that we might follow to help us with graphing a system of inequalities. So the first thing you would want to do is graph each inequality line individually. So don't forget your dotted and solid lines. Don't forget the shading, and you want to be able to do it lightly, shading up or shading down, but don't do it too dark. I'm going to show you in an example what I mean by lightly, because it's not all of the shading that will be your solution. There's only certain sections of shading that will be your solution. So we're going to discuss that. Actually, we'll discuss it here in a little bit here. So second, you're going to determine which region needs to be shaded to represent the solution of the system. So think about two different inequality lines. So you have two graphs, both have shading, and you're going to put those graphs on top of each other. Pretend like they're transparencies, and you put them on top of each other. And to determine the region that needs to be shaded as our solution, you would want to look and see which region overlaps in both of the graphs. So again, I will show you an example of that here in a little bit. And then we have shading that region darker to represent the actual solution. So you can erase the other shading. I'm going to show you how you can do it so that you don't have to do any other erasing. But it's this shaded region, the overlapping region of the two graphs, that is the actual solution. So we want to make sure that that is shaded nice and dark so there's no question about what the solution is. So now we're going to look at our example. So we're going to graph the system of inequalities here. So I have y less than 3x and y greater than or equal to negative 2x plus 1. Now if you don't have the y by itself, you're going to have to rewrite the equation so that the y is by itself first. Once the y is by itself, in our case, in both cases, both of these inequalities have the y by itself. So we have y less than 3x. Identify your y-intercept and your slope so that you can graph the line. So the y-intercept in this case is 0, 0, because you're not adding or subtracting anything. And your slope is the 3. So right there is our slope. So then we would graph that on the graph that we have. Make sure you scale your axes and label. So I want to label x and y. Then you want to scale it. So we need to put numbers on there. So I'm going to go every other one for my numbers, 2, 4, 6, 8, 10. So now my axes are scaled. So they're labeled with the x and y, and they are scaled with my numbers. So now I can actually graph. So 0, 0, it's right here in the center. And then we use our slope, 3, and you can make it 3 over 1. It's positive, so you're going to go up 3 and to the right 1. Up 3 to the right 1. So you do it all the way to the end. We can go the other direction. So up right is the same as down left. So just make sure your points are all in line with each other. Then determine whether it's a dotted or solid line. So remember, you're looking at your inequality, looking for the line underneath that represents the equals. That inequality does not have an equals, so we are going to do a dotted line. And then we do our shading. So always look at the inequality with respect to y. So this is a less than. Y is on the smaller side of the inequality. So less than means we go down. Now notice I'm just doing little lines for right now. That way I know which side of the graph I'm interested in. So I'm interested in the side that's down. Now we're going to do the other inequality. So y greater than or equal to negative 2x plus 1. So we have our y-intercept, which in this case is 0, 1. We have our slope, which is negative 2. And then we're going to graph. So 0, 1 is my y-intercept. So 0, 1. So plot that point. And then starting at that point, we're going to use our slope to get more points. Again, you can make it a fraction. So the top number tells you which direction to go, up or down. The bottom number is always to the right. Since it's a negative 2, we're going to go down 2 to the right 1. Down 2 to the right 1. So then we do a whole bunch. Since I went down right, up left, well, it'll give me some more points in line with the ones that I've already drawn in. Look and see what kind of line we want. There is an equals under that inequality, so that means we're going to use a solid line. And then we do our shading. So again, we look and see which side the y is on. It's on the bigger side of our inequality, y greater than. Greater than means we shade up. So you go to your line and you go up. So we want that side of the graph. Okay, and you could go all the way through, but notice again, I do them little. Then you identify which area was shaded both times. If you have more than 2 inequalities, you have to find the area that is shaded all the times you make a line. So every single line, there's that overlap, has the same shaded area. In this case, we've shaded here and here around the 2 lines. So it's that region that got shaded both times. So then that's the region that you'd shade darker. And that would be the solution to your system of inequalities. Here's a practice for you. So try to graph this one. When I go around checking your notes, I will check the graph and see if you got the correct lines with the correct shaded region. The one that tends to be a little tricky is this one. So remember to line it up with the y equals mx plus b. Identify your y-intercept, identify your slope, and that should help you get that one as well as the other ones graphed on this coordinate plane. And then we'll do some more practice in class next time.